and wrong is wrong, even if everyone is for it. This completely corroborates to the situation of AI ML in production within enterprises today. According to the 2022 Stanford HAI Index report, the year 2021 witnessed $93.5 billion in global private investment within artificial intelligence. Yet, only 1/3 of all machine learning production systems succeed, and those that do are not able to scale impact at commercial businesses. What is there for us is a community to learn from these success and failure stories. This afternoon, we will help you uncover some of those trends. Good afternoon, everyone. My name is Megha Sinha, and I run the MLOps GTM for Genpact. With me, I have Jatindra Singh,
Hello.
machine learning engineering architect within the AI/ML practice at Genpact. We will spend the next 50 to 60 minutes talking to you about the evolution of artificial intelligence and machine learning over the years, the many challenges that this brings to enterprises, the engineering community, and the business community, machine learning operations, or MLOps as we call it, as a probable solution to finding answers to those challenges. We will take you through a demo in one of the hyperscalers, and finally end you with a compendium of rich MLOps framework and best practices suitable for your industry that will help you get started on your journey of MLOps within your organizations. Now, if we were to talk about the evolution that this space has taken place, we understand that over the years, artificial intelligence and machine learning have existed for decades. However, what has changed are the business expectations from such solutions. Having said that, it is important for us to understand that each of the stages within the machine learning development cycle have also undergone a dramatic change. Right from your scoping and business requirements up until your model outputs in production systems, everything has undergone a complete change. So there was an era decades ago when the business decisions around machine learning systems only required you to build an output and your focus was on the model output. However, today, when you're actually looking at designing your machine learning systems, you're looking at them in totality. You're looking at integrating them within applications that can be consumed by people as end users. Number one. Number two, it places a lot of stress on the infrastructural complexities and therefore becomes a CIO agenda in understanding what are the various infrastructural needs, the complexities that we need to manage, the cost-benefit analysis, and whether this is even a viable thing for me to do as an organization. Moving forward over to the data ingestion stage. Up until a few years ago, we would typically have only one data source, maybe in an Excel or a CSV, where we would get data and we would build our models. Fast forward to today, you need to design data handling systems where you have real data, real-time data, and batch data. You need to build your ingestion pipelines, your transformation pipelines to be able to do all of that together. We understand that this is a challenge that needs newer ways of thinking. And finally, if we go to the model output stage, the model deployment stage, as I said, integration within systems becomes critical. The end user experience becomes critical, and therefore you need to design your systems that have low latency, that are able to wow your end users and your end customers. Now, going through this stage, obviously technological advancements have taken place, a lot of database system proliferation has taken place, and therefore the way we as a community have delivered onto these expectations also evolved. So early 2000s witnessed a stage when we would typically use proprietary tools and build our solutions. Today, we are in need of platforms, and end-to-end platforms, which gives the opportunity to all of the different stakeholders in an organization working on an AI/ML initiative to be able to contribute and deliver at scale. As you can see here in this slide, we talk about the differences between experimental AI and essential AI. So your experimental AI was an era where you typically did your projects for research or experimentation purposes, whereas today you do everything that you did in your experimental AI stage, plus a lot of other burden and a lot of other challenges that you have to mitigate, and there comes machine learning ops. Because now we look at these machine learning solutions as end-to-end integrated software engineering solutions with machine learning embedded and integrated into them. While we do understand these challenges, let us understand at the very onset what are the 4 broad typical things that businesses must understand and the data science community must understand to overcome and manage them at scale in organizations. I think the first very important thing are the objectives for which you are designing the system. In the experimental stage, you typically had one stakeholder, the data scientist, who would build on your model on a benchmark data set. So therefore, the model output and the performance was of paramount importance. Fast forward to today, when you're looking at various different stakeholders who are actually designing and building your systems, you will have competing, conflicting objectives. Let's look at the example of this restaurant recommendation app, which makes money by charging a 10% service fee on each order that is placed through this application. At the very onset, you would typically have your business leader for whom the primary importance is building a system where the model output is such that it refers to you the priciest of all the restaurants because you make more money. On the other hand, the objective of the data scientist would be to deliver a model such that users are most likely to click on the particular restaurant. As though this was not enough, the product management team steps in and says, we need to develop a model which has extremely low latency and is able to deliver results in less than 100 milliseconds because I have a hunch that my users are going to fall off if the latency is higher. There comes the concept of decoupling objectives. There have been several discussions and research around how decoupling objectives can be taken care of, and that is very important right at the scoping and the requirement decision stage when we're looking at these solutions. Moving forward to the output expectations, and like I said, every system has certain bottlenecks, and these bottlenecks emerge at various substages. So when we are talking about the training stage, the bottleneck is you require fast training and you require high throughput. Whereas when you are in the production system, you are now actually looking at fast inference and low latency. Data distribution, as we all know, within production systems is constantly shifting. It's messy, it's unstructured, and you have to work on it to clean it pretty enough. And as though this was also not enough, you sometimes might be working on user data. Therefore, it is important for us to be working within the boundaries of legal, compliance, regulatory concerns. As of the year 2019, only 19% organizations are actually looking at designing and delivering systems that are explainable enough. Is there an opportunity for us as a community to ride onto this wave of disruption and begin thinking of MLOps also as an MLOps plus a responsible AI system where you bake all of these things right from the beginning into your solutions? Now, while we've talked a lot about what these challenges are, what are the key considerations that we need to think of when we're designing machine learning systems as a software engineer, borrowing in from the software engineering parlance? The first and foremost is your business and ML objectives. No matter how complex your machine learning model metrics may be, if they are not able to move the business metrics, it has no significance and no value. And therefore, it is important that at the scoping and the requirement decision stage itself, we identify our business metrics and we work with the data science team to identify the ML metrics and do a 1:1 mapping to understand what exactly is that we need to move as a business. Now, there are 2 ways to do it. Number 1, organizations typically look at the industry benchmarks and they create that repository of business metrics, map it back to the machine learning metrics, and build their solutions. The other way to do it could be build internal metrics for businesses, just the way Netflix does. Netflix builds its own matrices and maps the ML matrices against those business metrics. So these are 2 options that are available out there. The second thing is reliability. When we talk about reliable systems, we're talking about systems that are correct. So you're talking about building correctness into the system. My system should be able to perform even in the face of an adversity. I should be able to catch all kinds of failures. Now, what are these kinds of failures that could emerge? Number one, you could have a system failure. Number two, you could have an operational failure. Now, the system failures are pretty easy to catch because you would typically have a deployment failure, or you would have a dependency failure where you have software packages and SDK kits that are not working in tandem with each other. However, what becomes more difficult to catch are the operational failures. Let's say, for example, we have a translation app which translates from English to French. And the system has been designed such that it should deliver results in less than, let's say, 5 milliseconds and should be 99% accurate most of the times. Now, while we can understand the latency of this system, it somehow becomes difficult to identify whether this has actually been able to give me a French translation correctly. And there have been situations where people have used such translation systems and gone on to do their presentations and faltered drastically and disastrously. So we need to build such kind of reliable systems. And what we will do when we want to build reliability are some of the things we will take you through to the second half of our presentation today. Then we talk about scalability. The moment the word scalability comes, we all jump in to think it is only about resource scalability. You know, you're talking about infrastructure scalability where you ramp up or you ramp down basis the needs. However, a very important factor in scalability is also the artifact management scalability. The way you would deploy one model versus the way you would deploy 100 models is going to be very different. When you deploy one model into production and you use a file-based management system to identify your artifacts, your metadata, etc., it's still easier to go back and recover from it. However, when you're talking about 100 models across the enterprise, all tied to each other, it becomes difficult. And therefore, you need tools, you need services to help you manage all this. Maintainability. And here comes the concept of platforms. Every individual contributing to a data science project, contributing to an ML project is critical. The identification of all these personas, their roles, responsibilities, accountability, and bringing them all together on one platform where they have no conflicting interests and they're not in the struggle to have one tool versus the other is important. And finally, adaptability, which I think also relates back to reliability, because here what we're talking about is versioning from the software engineering world. We talk about data versioning, you talk about model versioning, you talk about code versioning, and why all of this becomes important when you are in production systems. Moving further, we said there are challenges. We said there are certain things that we would want to do. Now the question is how. So we definitely need a framework that can be utilized to do all of this together, and also tools to make this framework a reality. When we talk about this framework, there are 5 important things that we need to be cognizant of. You definitely need to redefine your teams. Hiring 2 or 3 data scientists alone to run a large-scale project is not going to work anymore. You need various personas that can work together. You need end-to-end machine learning platforms, you need continuous model monitoring, you need continuous improvements, and not at the cost of system failures and system downtimes. You need to involve the IT team from the very beginning of your project decisions, because machine learning ops is critical for the CIO. It is critical for the CTO, and therefore these people need to be involved from the very beginning. And finally, like I earlier said, the responsible AI practices at all stages of your framework. If you look at this framework, you would see that across all of these different stages, there are certain things that we are tackling. And for all of these to be tackled, there are certain tools, there are certain services that need to be invoked and enabled. And this could be done in any technology stack of your choice, which your organization may be going after, or it could also be built using open source tools and systems. Now the question is, we identify, we understand that yes, MLOps is important for my organization. I need to operationalize and put my systems into production. What do I do? As with any transformational change in an organization, people, process, and technology are at the core of everything. However, we're talking about machine learning systems, and therefore, data becomes very important. And you need to have a robust data strategy wherein you're able to build, sustain, and maintain the data for utilization in the machine learning projects. Before we move any further with the MLOps or the data strategy in my organization, it's very important for me to take into cognizance where exactly I stand, what is the scale at which I'm operating today, and what is the scale I want to go up to. So we've identified that there could be 3 different scales broadly, and these could have overlapping elements to them. So you identify where in the MLOps stage am I. Am I going to build a minimum viable machine learning infrastructure where I can do continuous build and deployment? Or I need to go one notch up and build things at production grade, wherein maybe I have several models all talking within the same product. Or I am building several different products within my organization, each of them having various different models into them. The dynamics, the infrastructure, the system design, everything changes across all of these different stages. And therefore, what is it that you need? You've got to define your scale. Secondly, you have to identify your requirements for machine learning in production. There could be several more things that you might want to do, several more components apart from this that you might want to implement when you're implementing a machine learning system. So you have to identify which out of all of these or more are things that I want to build into my ML system. Do I want a feature store? Can I do away without a metadata store? Do I really need to have a code repository? So thinking behind this is you plan big, but you start small. So you can scale. Ever since the beginning of designing your systems, you need to have the scalability in mind so that tomorrow, when you really need to scale up, you can make those decisions quickly, swiftly, and move fast. And then finally, you need to decide the choice of your platform. Now, there could be 3 different things when you talk about the choice of platforms. You could have off-the-shelf ML platforms, you could have in-house solutions that you design with open source libraries, or you could have cloud provider ML platforms. But the one thing that is very important is to understand that these have to be language, platform, agnostic. So you can actually build your systems in any tool stack that you define for your organization. And finally, when you talk about your implementation pipeline, you define all of your MLOps stages, you define your sub-stages, and then you detail the scope within each stage, and you identify what exactly do I mean when I say data labeling or data streaming. Where is the data going to come from? How am I actually going to retain my paths and build those? You decide your tool or platform, and then you decide a RACI matrix, which is very important if you want to have accountability built in to your system from the very beginning. And once all of this is done, you are ready to at least get started with deploying MLOps in your organizations. Now I shall hand over to Jatin, and he will take you through a demo in AWS SageMaker. However, any of the hyperscalers today available in the market will be able to deliver to these expectations, and you can stitch and make an MLOps pipeline for you, even using open source libraries and platforms. However, we've chosen AWS for the sake of clarity, and we will walk you through the demo.
Yeah, thank you, Megha, for making it easier and setting the stage with such clarity and hustle, making my job easier. So yes, as Megha has mentioned that, MLOps is a discipline focused on deployment, development, deployment, monitoring, and automation of machine learning systems, which is actually a cross-domain exercise, involvement of multiple domain and people. So looking at all the verbosity of available tools and technologies, it's very hard sometimes to realize the right approach going forward. You can, as well as our choice of SageMaker is your solution, when you put it in place, may comprise of multiple technology stacks. But essentially, the core practices of MLOps remain same, underlying the approach that you have taken. And cloud providers like SageMaker or AWS have done a very good job of distilling these core practices under one umbrella so that you can make sense out of it, essentially in a session like this, which is time-bound. So let's look at some common challenges that we face and how essentially SageMaker features make us, are a solution to these challenges in a certain fashion. So let's look at the first challenge. The first challenge is actually enabling your data scientists to have access to your data platform, the infrastructure. So what exactly is the solution that your MLOps practice suggests? MLOps practice suggests everything as code. essentially everything is code, infrastructure as code. So we have a feature on SageMaker called AWS Service Catalog, which actually caters to this solution. So we have a portfolio of products already pre-configured with the policies and compliance guardrails built in onto your template, so that your data science have a kind of self-service facility to provision this this infrastructure, whether it is on an individual basis or on a project basis. Let's go on to the next challenge, is kind of bridging the gap between the model build and model deploy. So essentially this is a handoff process. Once the model is built by the data scientist, there is a handoff to the operational team. So essentially if you don't have any kind of traceability or tracking of lineage tracking or configuration management, it becomes that much hard. It will become an operational nightmare. Once what model, how it was built, what are the operational metrics, or how did it qualify to be a candidate model. So this is where your Amazon SageMaker model registry comes into the picture, and it solves this for us with robust tracking of all this model metadata with your experiments. Then we have end-to-end traceability. So here comes the age-old practice of CI/CD, which is not a new practice. Most of you would be aware of since time immemorial. But looking at data science, there are some additional constraints or capabilities that you would need. That is versioning of data, versioning of your model, and end-to-end traceability and auditability that CI/CD inherently brings to the picture. Then we have the challenge of building a repeatable and consistent processing for deployment models. So once you should have a repeatable and consistent way of deploying your models. Once you train your model, you may have to deploy it to multiple target environments, right? So continuous delivery and deployment again comes to your rescue, to giving you essentially a simple way to actually do your training and actually deploy it to multiple target environments without retraining required in between. Then comes the final challenge of monitoring models. Models degrade over time. It is a fact of life. Okay, and the reason may be multifarious. Like you can have the current ground truth be very different to the data on which a model was trained. Okay, which is essentially called data drift. There is a word coined for it. Or we may face concept drift. You have essential model monitoring infrastructures to observe these changes in data in the operational phase of your model in the production, so that you can detect these changes and actually revert to retraining as and when required. So let's look at some MLOps ready features, and let's take the example of a typical machine learning workflow and how it works. And they comprise of essentially 3 steps, your data preparation, train and tune, and deploy and manage. Let's walk through all these different phases and how and where we leverage MLOps ready features from AWS SageMaker and how do we do it. The first stage comprises of the data preparation stage. This stage essentially takes care of your data preparation, from data sourcing to data cleansing, transformation, and feature engineering. So essentially there are 2 features which are available with SageMaker, that is data wrangler and data processing jobs. Data wrangler is basically a GUI job, and both of these features are readily pluggable into your workflow. So data wrangler is essentially your GUI based feature which you can use and plug into your machine learning pipeline to do all the steps which is required of a data processing job. So looking at the data preparation job, looking at the SageMaker processing job is essentially a programmatic way to actually do the same thing. You can build your own customized data processing workflow stage and plug it into your machine learning workflow. Going forward, we look at the input and output from this particular stage. You have the raw data or a particularly clean data to an extent, which goes as an input to this stage, and the output of this will be train, validation, and test data. All the input and output on every stage of a machine learning workflow has to be versioned, okay, for the purpose of lineage tracking and traceability. So here we have the outcome of this stage as training, validation, and test data. It is versioned along with the data processing code which was used to do this processing. Your code might change, you have to version it at every stage. So when you go back and look back at a certain experiment, you may find out that, okay, I've trained this with this logic and this is the feature engineering logic that I've used over here. The next stage is the experimental tracking stage. So this is where your iterative model development phase comes into the picture, where you train your model and you evaluate it and do it in a cyclic process and tune it to your requirement till you hit a KPI measure that qualifies your model to be a candidate model to be deployed into the production. Okay, so SageMaker has this default experiment tracking capability, which allows it to, by default, track all the experiments that you have conducted, whether or not your model outcome from this stage is a candidate for deployment or not, irrespective of it. So essentially, from this stage, you again you see a set of data coming out, like model artifact experiment and your training code, which will be versioned. So once your model hits a particular KPI performance parameter, it may be RMSE score for a typical regression model, or if you're using a classifier, you have your FEN score, AUC score, typically whatever the choice of, maybe utter something. So typically whatever choice of poison is, it will qualify your model to be registered onto your model registry. The model registry will keep track of everything that has gone in in the building of this model, whatever the hyperparameters that you have configured or whatever data it was trained on, as well as the performance criteria or the outcome that you have from the model. It will be registered. Now, post that, once you have a candidate model, which is registered on your model registry, you will have SageMaker deployments kick in automatically. It also depends on the kind of decision you have built into your pipeline. It may be automated or it will need a human in the loop kind of scenario. We will be having a human in the loop scenario in our demo, which is upcoming. So now we have a typical essential pipeline which is required to which is needed to have a repeatable performance. You can have execute it repeatedly and derive outcomes. But if you are in need of additional bells and whistles, there are additional things that you can do. You have put in your model monitoring phase, which will keep track of your model performance over time and give you whether you have a data drift or alert you on a data drift or a concept drift, or even re-trigger a pipeline if you put your pipeline in an operational phase. You can have a feature store, which is nothing but a curated set of features which can feed into your training pipeline. So again, we'll have a detailed look at it. So now we have a look at all the different workflow stages, but how do we stitch everything together? How do we use all the benchmarking and the benchmarking as well as the lineage data that we are tracking, and how do we stitch them together to the model registry to back and forth all through the three stages? We have SageMaker pipelines. SageMaker pipeline not only ties together your workflows, but what it does, it has backend integration into a lot of AWS resources which enable CI/CD integration, which you get by default. We'll have a look at it and how SageMaker pipelines are important. Looking at the importance of SageMaker pipelines, we'll do a little bit of deep dive into how SageMaker pipeline and what SageMaker pipeline does. So essentially, one part of the SageMaker pipeline is the Python SDK, which is used to build your SageMaker pipelines and stitch the workflows together. So it was released somewhere 2 years back during the AWS reinvent event. We have the model registry, which is also part of the pipeline, which helps you to catalog and manage model at scale and trigger automated deployments whenever there is an event. It has built-in support for CI/CD, end-to-end lineage tracking. So it has by default integration with CI/CD facilities on AWS like code pipeline, code build, and so on and so forth. So you don't need to have extra heavy lifting that you need to do to get this going. We'll see how this all works out. So if we look at how all these different three stages of SageMaker pipelines come together, first we talked about the SDK, right? This SDK is what you use to stitch together your workflow. You train your data, you cleanse your data, prepare your features, you train your data, evaluate, and then register the model. So more often you build these pipelines in your build stage. But these pipelines can also be reused in your operational phase, where your model monitoring feeds in data alerts and triggers to trigger the retraining of your models. The second part that we discussed about is SageMaker model registry. It is basically a catalog of all model metadata that you have generated across your experiments. And then finally comes the repeatable way of how you provision and use these templates that I was talking about earlier in earlier slide. SageMaker projects give you the facility of creating templates across different stages of this workflow. You can have a template just for the deployment. You can have a template for the build and train. You have a template for build, train, and deploy, and so many more. There are a lot of other things, a lot of other templates available. Essentially, this just to demonstrate the flexibility that SageMaker projects offers to you in building these template guidelines. Let's go ahead and have a look at a demo so that how all this looks like in real life.
You need the laptop?
Yeah. Do I plug it in? इसको निकाल दो. लैपटॉप कहाँ लगा?
AWS SageMaker has only been chosen for the purpose of simplicity because we've identified this. There are several other platforms that we do work on and deliver solutions for our clients. And any of this can be achieved using any of the hyperscalers or even the other third-party off-the-shelf ML platforms, MLOps platforms that are available in the market.
Let me SageMaker, and we arrive at our page. The way, when you come to a SageMaker managed service, the first thing that you will face is creating a domain. Once you create a domain, you have to onboard users to it. Domain gives you the facility of integrating or providing role-based access to your users to the SageMaker console or SageMaker studio. And once you have the domain configured, you can add users to it. It may be a team onto a project. Essentially, we configure it that way organizationally. And while you configure the domain, you have a particular facility of adding SageMaker templates to it. That I talked about SageMaker catalog, right? You have pre-built templates available and will be available onto your SageMaker Studio facility once you enable it on your domain. So once you create the domain, you will have it's a question of toggle. Toggle it, the project templates will be available. We'll have a look in a minute. So we log into our SageMaker console. Open Studio for a particular user.
The network speed doesn't support our speed, right?
All right, so we are here. So once you get into the SageMaker console, you went to the create project option, select your projects, and click at the create project option. So here you see, as selected into our domain, we have pre-configured templates available to us. These are basically CloudFormation templates which provision the infra and populate it with the seed code that are pre-configured for it. Okay, we'll have a look at it, some of these templates. So we have selected a particular template for building, training, and deployment of SageMaker projects. And once you select this particular template, you have templates for just for deployment. If you have any other process defined for you on your organizational according to your organizational standard like airflow pipelines, etc., which training is a model, you can just leverage SageMaker for deployment. That's the flexibility that it offers. So for our demo purpose, we have selected a template called for model build, training, and deployment. We select the project and provide a unique name. Once you provide a unique name and click on create project, it will create a project for you with the seed code populated and the code commit repository is created. So now while this takes, I can do it live. Essentially, it takes a while to provision all this infrastructure and seed code populated with the seed code. Let's look at a pre-executed pipeline that we already have and see, what happens after we provision these projects. So you see that there are two code commit repositories which have been created, and these are populated with the seed code of a typical model build and deployment cycle. The first of these repositories contain the seed code for your model build workflow, and the second repository contains your seed code for your model deploy workflow. So as soon as you create this project and this code commit repositories are created, if you go to the pipeline, you will see that there will be a pipeline which has kicked off. This is the default CI/CD integration that we are talking about. You don't need to do any kind of heavy lifting, going behind, assuming roles, creating services, and getting it integrated with it. It is by default. And you don't pay for any of this. You just pay for the services, those are provisioned during the pipeline execution. So now you see that there are multiple pipelines which are executed over here, but I will look at one sample pipeline which has been in execution for some time now. And you will see a graphical representation or directed acyclic graph which shows you the different stages of this workflow. You have the pre-processes. We have taken a data set called abalone data set, which is the default data set that SageMaker provides. The processing data processing stage, the train model stage, the evaluate stage, and in essence the check MSC abalone evaluation stage. This is the evaluation stage of your pipeline. The evaluation stage, what it does, it has a quality gate on your model. So any parameter or qualifying KPI that you have defined for a model to qualify to deploy into production, this will evaluate it against that. And if it passes that score, it will go ahead and deploy this onto your staging environment. So, but that's not all. Deployment is not that straightforward once you get this model registered. So once we go to this pipeline, and let's go to the pipeline stage. We have the abalone pipeline. And you can see that this is a repeatable process. If you look at, there are 4 execution of this pipeline, but we have a create execution button here. If you click on it, it will create an execution for you, which is a name that you provide over here. Additionally, SageMaker provides you the facility of providing runtime parameters. Whatever you have defined on your pipeline, the runtime providers can be provisioned from here. You see the processing instance count, the model approval status, etc. These are the parameters that you can provide. I can provide a pre-approved parameter over here, and the model will be simply go on to deploy on staging if I mentioned is that approved instead of pending a manual approval. So now let us look at, leave it for a while, and let's go back to our source code repository that was created. So now, for every SageMaker user, there is a local home directory which is provisioned, studio user, which is basically an EFS directory. So you can clone this data. So now the question arises is how do I customize this to my project's requirement? So you can actually click on this file and clone this repository onto your local directory. Okay, and this has been pre-cloned for me. If I go to my local directory, I can see that the abalone data is present, both the deployment and the training pipeline are present in my local environment. If I go to the train deploy model, pipelines, abalone, you can see that all 3 stages of my pipeline are present over here. And this is what you can customize to your needs. Suppose instead of abalone, I have a churn analysis use case that I want to replicate. You can replace all these files, or you can customize this to your need and check in. So essentially what it will do is you create a new instance of the pipeline. There are some parameters that you need to change. If you open the pipeline, you'll have the source code which gives you access to all these pipeline name definitions, your evaluation state executions, and everything else. The fit method is also present in this pipeline.py. So you can essentially replace all these source code and rename your project and check it in. So what it will do, it will instantly kick off this pipeline with the renamed project and rename pipeline names for the project that you want to customize it for. So once we do that, once we have this pipeline executed, we can go over and have a look at what happened to the pipeline execution that was in play. We can actually go to the experiments and trials of the projects. So yeah, so as I talked about earlier, the experiments and trials, SageMaker experience is by default integrated into your pipeline. Anything, any pipeline run, anything automatically gets registered into your experiments. So each of your experiment will have a registry over here, and if you enter any of your experiment, you will have your pipeline execution. Every run of the pipeline will give you a different execution trial. If I go to the home directory, we'll have all the projects. I go to Abalone, I can see that there are 4 runs of my pipeline. These are 4 different experiments. And every input and output that goes into every stage of this pipeline execution will be registered and tracked. That's the level of lineage tracking which is available on SageMaker. So we go back to our projects and check out what happened to our model execution, the pipeline that we had executed. We go back to projects, model groups. You can see that there are 3 different models which has been trained on this and approved for deployment. The final one is pending over here. So final one is pending over here, pending our update status. Now, if we have a look at all our model registries entries, the metadata, the lineage data, the input, the output, and the performance KPIs that we have defined, and we come upon agreement that this model needs to go to production. We can come over here, change the status in projects to approved, and update the status. This will automatically trigger a staging deployment. Although you can customize this, you can automate this, you can do n number of things with it, but this will trigger automated deployment to staging. Once this is deployed in staging, this takes a while. You can go to the endpoints category and you will see once the deployment completed, you will see an endpoint appearing here, listed here. You can test your staging deployment with all the validation that you want to do, and then I will wear the hat of a DevOps engineer, and then I will go to the backend CI/CD pipeline and try to approve this for deployment to production. That approval, you have to understand that there are 2 personas here. One persona who approves the model for deployment to staging, and the persona who approves the model for deployment to production are going to be different, essentially. And if I go to my code pipeline, you will see that my build stage is there. It has reached the build stage. At some point of time, it will deploy to staging, and then I will have an approval stage over here, which I can select, give my approval and my reasons for this to be deployed to production, provided it meets all the regulatory, statutory, and organizational standards or regulations that you have in place for this model to go to production. You can approve it. This will go to production deployment. So this is how we had looked at how a model deployment to production MLOps pipeline on SageMaker can be used to have this model deployed to production. Just give me. What happened? You have something? Something has happened. I have to. Where is this coming from? Duplicate. Yeah. Yeah. So summarize what we have gone through. Just to summarize everything, we started with SageMaker projects, provisioning a SageMaker project, running a template. We end up creating a pipeline. If you look at the data scientist come over here, provisions a project, he clones a template, or he checks in a modified version of the template onto the SageMaker code commit. Once the code commit is code is committed to code commit, there is an event bridge event that is created, which triggers the code pipeline. Code pipeline in turns triggers a code build activity, which actually picks up the workflow code and starts building and packaging and deploying it. So once this cycle completes, SageMaker model workflow starts building and deployed and then starts executing. It will reach a state when it will register this model. Once this is complete, we will have the model registered to the model registry. Once the model registered on registry, it passes a certain KPI threshold, it will trigger another model event. It will trigger another Amazon event bridge event, which will trigger the cloud formation templates, which will provision and deploy the package, the model to production or staging. So in this case, we had 2 stages of deployments, 1 to staging, and then we have a manual approval human in the loop cycle, which takes this and deploys it to production. So yes, this was kind of a fast introduction to all the capabilities that AWS SageMaker has. And there is no one golden pipeline, let me tell you that. But whatever model or framework or tooling that you choose, essentially the core practices will remain same. So hopefully we have helped you map the terrain of MLOps quite well, so that you can go back and it will help you navigate this space in a more informed manner. With that, I would like to hand over the stage to Megha to conclude this session.
As we promised earlier, we would be leaving you with a compendium of MLOps best practices that we've curated in partnership with NASSCOM. This compendium was designed, built, and launched with the inputs received from ML practitioners, MLOps leaders, software engineers, because we understand that MLOps is an overlapping domain with software engineering best practices. And when we talk about MLOps, it's more than just ML modeling. If you have any questions related to the compendium per se or anything that you may want to ask us, we are available at the booth downstairs and you can reach out to us. Thank you.